In this video, we will do an application example utilizing right triangles using trig functions to solve a right triangle. So um, this problem says a person in a boat floats near a cliff known to be 112 meters tall. The person uses a sextant to find that the edge of the cliff has an angle of elevation of 35 degrees. And we'll go over what does angle of elevation mean. And the question says, how far from the base of the cliff is the boat? Okay, so what does that mean? So if you we'll do some preamble, then we'll actually solve the problem. So if you are standing somewhere and you're looking straight forward, we'll say that your angle at which you're looking is 0 degrees. You're just looking forward, right? Now, if you look up somewhat, let's say you are looking up, you're tilting your head or your eyes or whatever. Let's say you're going up like 20 degrees. We'll call this the angle of inclination or elevation, depending on the terminology. Inclined or elevated kind of mean the same thing, right? Angle of elevation slash inclination. If you're looking down, let's say 20 degrees, right? This is the angle, 20 degrees of, well, declination would be down. Elevate. Trying to think what would be the opposite of that. So I'm just going to go with declination for now. Whatever word means down. Maybe I'll think of it before the video's over. What's the opposite of an elevator, right? Anyway, so that's what that means. So we have a cliff. I'm going to draw a diagram, I guess. So we've got a cliff, and we got water, right? And there's a person in a boat. And one of the things to think about is, are we going to worry about the height of the person? Let's say we're not going to worry about how tall the person is. We're just going to ignore that and not worry about that. So this person is using their viewfinder to see what is the angle of elevation. Basically, a sextant is a thing you look through, and it measures the angle that you're pointing up to look through it, right? You can make one have a protractor and some string and a coin. It's pretty simple. So let's say that normally if they're looking straight forward, that would be like this, right? But their angle of elevation is 35 degrees. Okay. Now, the cliff is known to be 112 meters high. Okay. Well, basically, we're getting, when we do this, I'll try to do this in orange, I guess. We're getting a right triangle. Well, let's do that. Let's call that close enough, right? And then this is a right triangle. And the question is, well, how far away is the boat from the base of the cliff? How far is that side of the triangle? How long is that, right? Well, basically, I can think of this angle as having 112 as the opposite side of the triangle and having the question mark side be the adjacent side. So this would be opposite over adjacent. So I'm going to say that tangent of 35 degrees, that is equal to 112 over the thing we're looking for. I guess I'll call it x instead of question mark. So let's do that. Let's call it x. Okay. Now I just need to solve for x, and I'll know how far it is. So I guess I will multiply x on both sides. So x times tangent of 35 degrees equals 112. From here, I can either divide by tangent. Oh, I'm running out of space here, so let's do this. Put it there. So from here, I can either say I'm going to divide by tangent 35 degrees on both sides, or if I want, I can multiply by cotangent of 35 degrees. It doesn't really matter. I'll say I'm going to divide. So x equals 112 meters over tangent of 35 degrees. Okay? And that's my exact answer, but of course, we want a tangible amount. How much is that? Because I don't I don't know tangent of 35 degrees. I mean, I could estimate, I suppose, but we want to say how far away is the boat. We need a more useful number. So I'm going to say I want 112 divided by, and I want to make sure my calculator is in degrees, not radians. Good, it's in degrees. So divided by tangent of 35, and I get 159.953. Okay, meters. So we can say x, or rather, how about this? Let's put it in a sentence. The boat, about, the boat is about, let's just say 160. It's really close to 160, 160 meters from the base of the cliff. And there we go. That's the result we wanted. Sometimes it's a good idea to go back and read the question, double check that that really is what you were being asked for. But in this case, how far from the base of the cliff is the boat? Yeah, that's exactly it. I'll also point out we didn't worry about the length of the boat. Is the person sitting at the prow or the stern? None of that. Just let's not worry about those details. Um, in a much later course, you'll have to deal with that kind of thing, but in this one, we're just going to not worry about those details unless the question specifically says that we need to.